Hey, look, I have a camera. I'm excited. This is so much better than trying to do slides. Though I might do slides also. Anyway, so I've noticed that some of you need a review of integration techniques. So let's do this. This pen probably sucks. Yep, it sucks. Let's see if I can find a better one. Okay, it seems like pretty much everyone is okay with the basic power rule. So if you have the integral of x to the n dx, you'll get x to the n plus 1 over n plus 1 plus c, of course, as long as n does not equal negative 1. If n does equal negative 1, that means you're integrating 1 over x, which is the natural log of x, plus c. Now, for substitution, and of course you should have all the functions memorized. So if you know that the integral of e to the x dx is e to the x, and you know that the integral of cosine dx is equal to sine of x plus c, and all the other ones. Okay, I'm going to look at techniques though. So substitution. Substitution is a way of undoing the chain rule. So when you see something, to determine if you want to do the substitution, you are looking for something of the form function inside of a function with the derivative of the inside sitting on the outside. Derivative. Okay. And the derivative of that. Okay. So the derivative, function inside of a function, and its guts are on the outside. So then it wraps back up to be f of g of x plus c. Now, as long as we have this give or take a multiple of a constant, we can do this. So example, let's say we have the integral of e to the 2x dx. Well, the derivative of the inside is 2. We don't have a 2, but we can divide by 2. I'm trying to find another pen. Sorry, it's taking so long. So I really want to have a 2 on the outside, but I don't have it. So I put a 2 on the outside and a 1/2 on the in. Yeah, I do that. 2 here, 1/2 there. So basically I have my f with g on the inside and the derivative of g sitting on the outside, but I do have this extra 1/2 floating around that I want to keep. So I integrate that and I have 1/2 e to the 2x plus c. As long as you have an mx, and the m is, even if the m's not out here, you can integrate it. And what do I mean by that? So if I want to integrate sine of 3x dx. Well, the integral of sine is negative cosine. Inside doesn't change, but I needed that 3, which I don't have, so I have to divide by 3. This is the same process. I have one of my weird functions with a linear thing, mx, on the inside, so I'm going to end up with the function with 1 over m on the outside. One thing that might be a little bit harder to see, I'm about to get a cat, come here. Let's see, I have 1 over 1 plus 4x squared dx. Now when I see an x squared on the bottom, a positive x squared on the bottom, and no x's on top, I immediately think arctan. I need to figure out some way of massaging it into arctan. So this is the same thing as the integral of 1 over 1 plus 2x squared dx. So I have my arctan. I don't have the 2 that I need. The derivative of the inside is a 2, so again I will have 1/2 arctan of 2x. Sometimes it gets more complicated, but these you should be able to do in your head. If I want something, I've got a cat. I can't believe she's just avoiding the can. Oh. Go away, kitty. Sometimes they get more complicated. You have to do some jerry-rigging, but I'm trying to think of a good example. Oh, here's one. Integral of x plus 1 over 1 plus x squared dx. That's a cool problem. I see the derivative of the bottom is 2x, and there's an x here, but also says it's stupid 1. But one thing that's really nice about integrals is you can split them up. So here, I've got the derivative of the bottom is sitting on top, give or take a 2. So I've got that 1/2. That's the natural log of 1 plus x squared. And this is the derivative of arctan. Okay, so now let's try integration by parts. Integration by parts is a way of undoing the product rule. So you remember you have, if you want the derivative of u times v, you get the first times the derivative of the second plus the second times the derivative of the first. Yes, kitty. And so if I integrate both sides, the integral of a derivative, they cancel out, they're inverse operations. So I get uv equals the integral of uv prime plus the integral of vu prime. This should be dx. And let's see, how do we solve it for one or the other? Du is what I want. Okay, sorry, I'm trying to remember which way we write the formula. So I have, solving for this one, I'll have the integral of u v prime dx is equal to uv minus integral of v u prime dx. That sounds kind of weird. Let's try it again. The integral, oh! Sorry, technical difficulties. The cat decided to knock over the camera. Little bitch. Okay, so the integral of u dv is equal to uv minus the integral of v du. You're probably more used to seeing it that way. Okay. So let's do some examples of this. Let's go back to here. What you were looking for when you do integration by parts is you're looking for where there's two different types of functions, right? It's when you've got trig and polynomials mixed up. You've got, that's weird. Why is this thing's shaking? Yeah, trig and polynomials mixed up, or two different types of trig, or e to the x and trig. If you've got two different types of functions playing there, that should scream to you, I need to try to do integration by parts because I want to get those two functions apart. Okay. So, okay. So let's say I have x times e to the x dx. Now if I want to integrate this, the first thing I do is I look for substitution. There's no function inside function except plain old x, and letting x equal u is just it's not a, don't do that. That's just rewriting it from apples to oranges, and it's the same thing. But I have an x here and an e to the x here, so I've got two different functions going on here. So I'm thinking by parts. I'm going to let my u equal x and my dv equal e to the x dx. That's what I have to label. I need to look at my integral and say, okay, what part of it's going to be u and what part of it's going to be dv? How do you choose what's u? Well, typically you want the u to be the thing that when you take the derivative, it starts going away or it gets easier. So I think, let's see, what is the, I think the acronym is LIAT. So you've got log functions would be your first choice, no logs. Inverse trig. Ah, that's too long. Algebraic. which means x's and polynomials, that sort of thing. T is trig, because trig's not going to go away. You take the derivative or integrate a trig function, you get another trig function, like exponentials. Exponentials are like gum on your shoe. You're never going to get rid of them. Okay? So exponentials are almost never used for your u. Now, of course, if you've got just trigs and exponentials, and you're screwed anyway. So 6 and 1/2 does the other. So, but here I have an algebraic expression. I've got a u equals to x. If the derivative of my u, the x goes away. If I integrate my e to the x, it's still e to the x. Okay, fine. So my formula says I want to have u times v minus the integral of v du. And I visualize this typically because I always write it in this way. This guy goes out front, and this is in the integral. So uv is x e to the x minus the integral of v du is e to the x dx. That's easy to integrate. Now, what if we mix some things up? What if I had the integral of x e to the 5x dx? So I got some things going on here. The derivative of 5x is 5, so I'm still not doing substitution. And I have two different functions here. I have my x and I have my e to the x. I see a baby substitution in my future, but we'll do that when we get to it. So there's my algebraic. I'm going to let u equal x. I'm going to let dv equal e to the 5x dx. When I integrate my x, I get dx. Integrating e to the 5x, remember we did this way at the beginning, if I can find the sheet? When you integrate e to the mx, you're going to get 1 over m e to the mx. Just replace that 2 in your head with an m. So here, v becomes 1/5 e to the 5x. So I have the diagonal line front, which is 1/5 x e to the 5x minus the integral of 1/5 e to the 5x. Copy this stuff down. It's not changing. Minus e to the 5. Ooh, that's kind of weird. E to the 5x. Integrate it again. I'm going to have another 5 on the bottom. So I've got 1 over 25. E to the 5x plus c. That's integration by parts. And there's some weird stuff you can do with the trig and the exponentials, but we're not going to hit that kind of stuff.